of our physical science chemistry review, so the stuff we learned in 9th through 10th grade. So let's jump into it. This is the kind of the big topics we'll review, but we'll get through them right now. You've seen all this before, but it's been a year or two, so we're going to make sure we review it so it's at least somewhat fresh in our mind, but we are going to go a little quicker than normal this year because it is old material. So if you don't already know, chemistry is just studying what matter is made of, how it's arranged, and the properties and changes that it undergoes. And if you don't want to remember what matter means, it's anything that has mass and takes up space. So pretty much anything you can touch, feel, taste. Really, if you look around the room you're in, there's probably only one thing in it that's not matter, and that would be like light. So energy is not matter, but for the most part, everything else, air is matter, your desk is matter, you're made of matter. It's all matter. There's a few examples. Elements, so when you hear of the periodic table of elements, yes, everything on that periodic table is an element, and by definition that means it's something that can't be broken down or separated into simpler substances chemically. You can break them down, but they don't act the same anymore, so they're not considered an element at that point. Atoms are the smallest part of that element that still acts like that element. So for instance, gold is an element. All metals, which gold is a metal, conduct electricity. They can be like hammered and flat, things like that. And that means even a single atom of gold would also be able to have those traits like conducting electricity. There are smaller things than atoms. There's parts inside of an atom which we'll learn or refresh our memories with later. But atoms still retain the properties. So if you break an atom down into protons, neutrons, electrons, those no longer have the same properties as the element. A compound, like if English, a compound sentence, it's more than one. So a compound is a substance made of atoms of two, which is more than one, or different elements that are chemically combined. So H2O, water, has H's and O's, hydrogens and oxygens, which are two different elements. They're joined together, so that makes that a water compound. Every compound is also different than the elements within it. For instance, table salt, which you pour on your food or it's in food, is sodium chloride, NaCl. Well, chlorine, which is made up, part of what makes up salt, is a poisonous gas. Yet when it combines with sodium in a 1-to-1 ratio, it's fine. We eat it all the time. So the compound is very different from the different elements that are in it. A molecule, when atoms are joined together, and it still acts like that. So if you look at this picture here, you'll see this top picture is a water molecule. The big molecule, atom in the center is oxygen. Two little ones here where I'm pointing to are the hydrogens. Here is an oxygen molecule, so two different atoms of the same element, oxygen. Then we have a giant sucrose molecule, C12H22O11, a bunch of stuff stuck together. If you want, you can, if it's still confusing, you don't remember it so well. This is a short video, but if you Google or YouTube and type in this topic, it'll come up there, but I'm not going to play it. I'm going to assume the best, that you remember this stuff well, but if not, yeah, go watch this 2-minute video to help refresh your memory. I'm running through some more vocab before you put anything in your notes. Pure substances versus mixtures. Everything on Earth is either a pure substance or a mixture. A pure substance is something that has definite chemical and physical properties, so all elements and molecules and compounds would fit this. Mixtures are a combination of two different things, two substances that are not chemically combined. So good way to think of a mixture would be like chicken noodle soup. You got chicken broth in there, you got chicken chunks in there, you got carrots, celery, whatever else you might put in there. They're all thrown in there. They're not stuck though. You could pick out, like if you don't like carrots, you could pull out all the carrots. So a mixture is different stuff that's just stuck together. And if you're a mixture, you're either a heterogeneous mixture or a homogeneous mixture. Homo as a prefix means the same, hetero means different. So a homogeneous mixture looks like it's just one thing. So like for instance, pop. If you have a can of Pepsi, a can of Sprite, it looks like one thing, even though if you read the ingredients, there's a lot of things. So homogeneous mixtures look like it's just one thing. Air is in front of you. It's made of carbon dioxide and water and oxygen and nitrogen. Those are different things, but air is clear. It looks like one thing. It's homogeneous. Heterogeneous mixtures are not like that. So like the chicken noodle soup we mentioned earlier as a mixture, that would be heterogeneous because you can see different things in there, and every bite you take is different. You don't have the same exact amount of chicken and celery and carrots in each bite because it's not spread out evenly. So if you can tell by looking at it there's more than one thing in it, it's a heterogeneous mixture. If it's a mixture that looks like one thing, it's homogeneous. Energy is all classified as either a mixture or a substance, a pure substance. If it's a mixture and it looks like one thing, it's homogeneous. If it's a mixture that looks like more than one thing, it's heterogeneous. If it's a substance, it's either an element, so just something you could find on the periodic table, or it's a compound, which is more than one element joined together. And we'll practice that again. We're not going to just assume you remember it. We're going to still do a little bit of work like we did when you first saw this stuff. Again, you could pause here if you need to kind of get these definitions better in your head, but we've talked about all this. If I would pause here and try to fill out as much of the first part of the notes as you can. Pause it now. If you missed any, fix them, or didn't know any, make sure you copy them. So pause that here. I'm going to skip ahead here in a second, so just pause if you need to copy this. All right, so one of the other big things we learned back in 9th to 10th grade was physical versus chemical properties. Physical properties, you can see those without changing the substance. So the smell of something, the color of something, those are properties you could just look or smell, the texture of something without changing it. A chemical property you can only see when the identity of the object changes. So flammability is a chemical property. It means how something burns. Well, you don't know that unless you change it. So if I have a piece of paper and I want to see how flammable it is, I have to burn it, but now it's not paper. So that's considered a chemical property. And remember, chemical starts with CH, so does the word change. So chemical means something changes. In a physical property, it does not change. So go ahead, pause here while you put that in your notes. All right, physical properties. We said you can see these, observe these without changing the substance. So basically anything that comes from your senses. So feeling, sight, hearing, smelling, tasting. Mass, how heavy something is, that you don't have to change it to feel that. Volume, how much space it takes up, you don't have to change what it actually feels like. Even density, which I do believe is coming up here in a second. But here's some more physical properties. You don't need this part on the test, but all physical properties, if you remember, are considered intensive or extensive. And intensive means it doesn't matter how little or how much you have of it, the property is the same. Extensive would mean the property varies based on how much you have it. But some of those physical intensive properties are color, odor, and then some new vocab. Well, not new, but you haven't seen it in a couple of years. Luster, how shiny something is. Malleability, remember mallet is like a hammer, so malleability means I can hammer something and it doesn't break, it just flattens out like metals do. Ductility means I can pull on something really thin and it just turns into like a wire without breaking, which metals also do that. More physical properties, conductivity, will something allow electricity to flow through it? Hardness, how easily can it be scratched? Melting, freezing, and boiling point are three that often people missed on the test. If you missed a question from this test when you took it the first time, the test that was 9th or 10th grade, you might have missed one of these three because it seems like it's changing. The boiling point is the temperature which, like for instance, if it's water turns to steam. So it's changed, right? No, it's still H2O. So phase changes going from melting an ice cube to a puddle of water, heating a puddle of water till it turns to steam. Those are not changing chemically. They're still H2O, so those three, melting, freezing, and boiling points, are considered physical properties. Hinted at this earlier, density is a physical property. If you remember, we did the lab, we had 6 little cubes. They were all the same size, but some of them were very heavy, some were very light because their density varied. Because density is how much mass you have divided by the volume, so how much something weighs per the size of it. And that doesn't change. That's a physical property you don't have to change. Just like the first time, pause here and try to fill out the next vocab section. Pause here to check how you did or fix any that you missed. All right, On to chemical properties. We remember chemical means change, so these are properties that you can only see if they change. So this word react, that's a key giveaway. It means it's reacting to change. So how reactive is it to oxygen, reactive to air, reactive to anything? If you see that react word, it's going to be a chemical property. We already said like flammability, does it turn on fire? These are hard to observe traits because they have to change the substance to observe them. If you look here, you don't have to write this down. I know it said that, but I changed it for the review year. Each of these substances have a physical and a chemical property. So it's not like, oh, some objects only have physical properties or chemical properties. So look at wood. An example of a physical property, it's grainy. It feels grainy. So you could feel that. You don't have to change it. Flammable, in some things, their chemical properties, even non-flammable, would be an example. So all objects are going to have both chemical and physical properties. Physical and chemical changes are just changes that don't change what the substance is if it's physical, and they do change what it is if it's chemical. For instance, rip a sheet of paper in half. Well, you still have paper, it's still the same substance, so that would be a physical change. If I smash something, well, I broke it, but it's still the same substance. It's still made of the same chemicals. And remember, melting, freezing, and boiling are also considered to be physical changes because they are the same chemical formula. Melting an ice cube is still H2O. Chemical changes, we make a new substance. Something new is formed, a new chemical composition, new formula. Burning things, cooking food. Yes, cooking is an example. It does change. You can tell it changes because when you cook food, it smells. That means you've created a gas. You've made something new. That gas wasn't there before. Here's some other examples. Remember, physical changes, it's still that substance. So if you crush something, bend it, mix two things, well, they could be separated, cut something in half. And again, melting, freezing, and boiling are physical changes. Chemical changes do make something entirely new. So reactivity, flammability, but here's some other ones that you might hear. Iron rusting. When iron is left out in oxygen long enough, it forms iron oxide, which is rust. So it's now actually something new. Copper over time turns to brass because it reacts with the air. That's something new. Whenever we cook or bake, yes, you're going to smell gas. Well, that gas is new, so you made something. And if you've ever seen spoiled milk, it's disgusting. What was once a liquid now has little solid chunks that look like cottage cheese in there, so that's a new substance as well. So again, chemical properties can only be observed when you change the substance, like burning something, like we've said a few times. And there's our milk example, our freezing example. You can pause here if you want to read it, but it's just more examples like we've been talking about. And again, the most common errors you're going to see are melting, freezing, and evaporation. Those are physical changes because it's still like H2O if it's water. Diluting a solution is a physical change. So let's just say I add a bunch of water to like paint and it gets paler. Well, it's still paint. It didn't combine physically with the water, so it would still be a physical change. Go ahead and pause here, and then you are done once you finish this slide.